So welcome to this is the Further Math Support Programme online revision session for AQA Statistics 2, and in this session we're looking at hypothesis testing. So, there's a lot of language associated with hypothesis testing. We need to understand the concepts of null and alternative hypotheses, what type 1 and type 2 errors are, understand the concept of significance levels, what test statistics and critical values are, what do we mean by critical region, and what do we mean by an acceptance region. We need to do effectively two types of tests. We need to test for the mean, where we know the variance, and mean, where we don't know the variance. We can also be expected to approximate two normal distributions and test as well. So, January 2011, question 5. Now there's a lot of things you just need to write when you're doing hypothesis tests. My advice is never to cut corners with these. Just make sure you know what you're doing. It's also very important that you choose the correct tests. Okay, so here we go. 2001, mean height of students at the end of their final year was 165 centimetres. Great. In 2010, David and James select a sample of 100 students who were at the end of their final year at this school, and they recorded their heights and found that x bar was 167.1 and s squared was 101.2. Now, notice it's s squared. It's a sample statistic here, okay? So, to investigate the claim that the mean height had increased, David and James each correctly conducts a hypothesis test. They use the same null hypothesis. However, David uses 5%, James uses 1%. Okay? So what we're asked to do first of all is to write down the null and alternative hypotheses. Now it's very important here, this is a parametric test, so we need to state the parameter. The parameter that we're looking at is the population mean, and we're testing to see whether the population mean is 165 or we want to see if it's greater than that. That's what the question is actually stating us to do. Okay? So it then says, determine the outcomes of each of the two hypothesis tests. Well, the significance level really just depends on what critical values we're going to be using. It doesn't really do much more than that. So we need to work out our test statistic. So our test statistic is Z is equal to x bar minus mu, all divided by, in this case, it's going to be S over root n. Okay, that S could be sigma if we know it. Okay, so let's calculate this. So what was x bar? X bar was 167.1. The mean was 165. The mean is what is in your null hypothesis here, by the way. And then we're going to divide this by 101.2 divided by root n, which is 10. And if we calculate that, it's going to give me a value of 2.09. Okay, so now we consider each one. So let's consider David. David was doing a 5% test, and the critical value for a one-tailed test is 1.6449. We get that from the tables. Whereas for James, he's a 1% test. This is one-tailed. I know it's one-tailed because that's how I set up my hypothesis. The Z value turns out to be 2.3263. Okay, so here I can see that this is called your test statistic. These are your critical values. So here, what I can see is my test statistic is greater than my critical value, whereas here I can see that my test statistic is less than my critical value. So this leads me to reject H0. This leads me to accept or not reject H0. Okay? So we then need some comments. So here, what does this show? So this is evidence to suggest, some key words here. So it's evidence to suggest that the mean height, not the height, the mean height has increased, because it's one-tailed, we need that as well, has increased from 165, I prefer putting my units in as well, at 5%. Whereas here we're going to say there is no evidence. And again, please don't be lazy, write it all in full. So no evidence to suggest the mean height has increased from 165 at 1%. Okay, so again, just make sure you've got the, just Just make sure you've got the full idea there. Okay? So state why both David and James have made use of the central limit theorem. Okay, well, the issue here is why have we used the central limit theorem? Well, firstly, n is large, so that's important, but we're actually not told very much. If you think about it, we're not told that they're normally distributed at all. Okay, so this is an approximation. So n is large, we don't know. So that's not a reason, but that's why we can use the central limit theorem. So we don't know it's normal. Okay, that would be a reasonable one. Population not stated as being normal, so we don't really know. Okay, sorry, I need to go through the marking of the previous question. So how is this marked? Well, you get B1 here, we've established that already. Let me change colour. Okay, so you get method 1, accuracy 1 for your test statistic. You get B1 for using a correct critical value. Either of them, don't really mind. You get A1s for accepting and or rejecting in each case. You then get an E1 mark for each of these. Okay? So, part B. Give a reason for your answer in each case. Determine whether a type 1 or type 2 error or neither was made in the hypothesis test. So what did David do? Well, David rejected H0. We found out that actually we should have accepted it. That's a type 1 error. Okay, type 1 error is rejecting H0 when you shouldn't have done. Okay, this guy was fine. He accepted H0 and he should have done, so that's fine. So no errors. Okay, so you get M1 for stating that he's rejected H0 when it was correct, and then an A1 for stating it there's a type 1 error. So here, accepted H0 when correct, we need that as well. That's going to get your method mark there, and that leads to no error. We'll give you your second method mark, your accuracy mark. Okay, so June 2010 question 1. This time we are given raw data, which is quite nice. Now notice there's only 12 pieces of data. That's not very many. Okay, just be very, very conscious of this. So in order to investigate, we only know about the mean being 79. We know nothing about the variance. So what we need to be doing here is a t-test. N is not greater than 15, sigma unknown. Okay, so we have to be doing a t-test in the same way that you would do for a confidence interval. So what do we know? Well, we've got to work some stuff out. You can work out x bar, and we can work out s squared. Now you can do that on a calculator, to be honest. You don't need to do it by hand, because you're only going to get 2 marks for it. Okay, 1 for each mark. So please just type them into your calculator and use the tabular facilities on your calculator to do this. Okay, now what is the assumption? Well, to do all of this we need to assume normal distribution. Because n is small, we can't use the central limit theorem. Okay, so if we want to do this, we need to assume this. Okay, and that's going to give me a B mark. So now, let's formalize the test. So what do I need? I need H0, I need H1. Okay, so H0, we're testing whether the mean is 79. H1, we're testing that the mean has exceeded 79. So notice this is a one-tailed test again. Okay, great, so let's work out our test statistic. So our test statistic must be a t-test value. It's the same concept, so it's x bar minus mu over s over root n. So it's the same test statistic as you would do anyway. So this is going to be 82 minus 79 divided by 5.58, that's the square root of s squared, divided by root 12. And that's going to give me 1.86. Okay, so the next thing is I need to choose my things. So we've got n pieces of data, we're looking at Tn minus 1. So we're using 11 degrees of freedom, and we want to do this at 5%. Okay, it's 5% one-tailed. which gives me a t-value of 1.796. Okay, so let me go back a slide, because I like putting this all in one place. So your critical value is t11, and that's 1.796. So notice your test statistic is greater than your critical value. Sorry about that. Okay. What does that mean? Well, it means we're going to reject H0. Okay, so there is sufficient evidence at 5% to, and in this case we can say, support Judith's belief. We're quite happy with that because she has a belief. Okay, so let's look at how this is marked. So what are we going to get? So we've already talked about the B1, B1, B1. You're then going to get M1, A1 for your test statistic. You're going to get B1 for your critical value. You're going to get A1 for rejecting H0, and an explain mark for doing it in context.